Hello everyone. Today we go with 5.1 um, random variables. So this one we can say probability distribution. Distribution. Whenever you heard as distribution for the random variables, um, so we can do this. Of variables in which of the value take depend on the chance. This variable create the probability distributions. So for this, if we this one look like for the algebra. When we do the algebra, this one is algebra. Um, like for example, 2x equals 6, and we solve x, so x equals 3. But in this case, we use the probability. Um, so probability. So we still have a 2x equals 6. So it's the possible change. The possible for x equal 0, x equal 3, x equal -2. So if x equal 0, as we can have as 1/4 of that. Oh, this one is 1/2 of this, and this one 1/4 of this. So we can go with the total because the total of this one it should be 1. So this one is probability ability distribution. Um, So notation, x is the random variables, and small x is the possible value of x. So obviously, so this one is the given to you. Obviously, obvious, you need to find them. So of this, so this one is probability of p of 3. So P of 3, so that's 1/2. Therefore, P of x equals 3, so it should be 1/2. For this, when you see that this one is really thin, so P of x. So P is big X equals small x. So this one is clearly, this one really clear. They give you that. So now we go for probability. So we go for probability. We have P of x greater than or equal to 0, or sum of P of x equal 1 and so from x. So we can go with example for this one. So we can check. After we're done is we can check. Is that we can check stop this one. So so this one is we can add all this up. This, we can add all this up. That is the sum. Is that the sum of this? So we can add all this up. So on this side, the sum of this one should be as 1. So in here, P of x greater than 0. So so we have P of 1 plus P of 4. And this one, P of 1 is 0.3 plus 0.1. So this one is 0.4. Or we can have another example. Example. So we have X and P of X. So X is 1, 2, 3, 4. And then P of X, K, 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 K. So after we add other K up, this should be is 1. So therefore 4K equal 1. So K equal 1, 4. So let we do this one, for example. Let's access the outcome and to buy the raffle ticket. The price $500. The number of tickets 500 and ticket price is $2. So like for the when you buy the ticket, raffle ticket, of course in there they have only one ticket. So the chance we can say district and random variable. So like we have the winning possible. If we pay only $2, so the winning possible is 490, and then if we lose $2. If we win, we win 490, 498. If we lose only $2. And for the P of X, this one out of 500. That's just only one chance we can win, right? Only one ticket we can win. All the rest, and that's just we lose. So we can add it up. So this one is 500 over 500. So this one only one winning number. So we go for the next one. Let's X number of the boy in the family have 3 kids. So this one in the chapter or in the section 4.1, in the example 1. So the total is 3 kids, right? So we have a 3 kid. So the possible, so this one is for the 3 kids. So we have either boy or the girls, right? The boys, the X number is the boy, and then the rest is the girl. So if X is 0, we have so this means like no boys. So only one chance. So 1 out of, so this one's 1/8. Remember in the 4.1, I have the some of the diagrams when a boy is when a girl, and this one a boy. So 4.1, you can go back and you can check up this one. So for this one, if 0.1 boy, 2 boy, or the boys, so we have 3.8, 3 over 8, 3 over 8, and 1 over 8. So this one total should be 8 over 8, so should be this one. So expect value and a variance. So expect value we can say is E of X equal mu and this one should be the sum of x and p of x. For the variance, so this one is sigma square equal e of x square minus mu square, or we can get standard deviation s square equal sigma of x square minus sigma of x square over n and over n minus 1. So at example, we can see this. So x is negative 3, 0, 3, 5, and the p of x is 0 0.2, 0 0.4, 0 0.3, 0 0.1. So we can have x of p of x or x squared of p of x. So we can have minus 0.6, and this one, so that's one, so this one is minus 3 square 0 0.2, so this one is 9, 0 0.2, this one 1.8, so this one is 1.8, and this one is 0 0.0, this one 0 0.0, 0 0.9, and 2.7, and 0 0.5, 2.5. So we have the variance. Variance is sigma square. So the variance is sigma square equal e of x square minus mu square. So this one, so we have the sum of this. So we go back here and we can add them up. This one should be 1. This one is 0 0.8. So this one is the mu, and expects of x. And this one is 7. So this one is e of x squared. So 7.0 minus 0.8 square. So we got 7.0 minus 6.64. So we have 6.36. So this one is variant. So this one is the variance. So when we take a square root of sigma, so take a square root 6.36. So approximate power is 2.52. So this one is standard deviation. We want to find out a standard deviation. So we can go with another example. Let's X is the outcome if you buy a raffle ticket. Like I said before, we have a ticket, so $2 for the ticket. So if we go like that, we lose $2, but we win. If we win at 498. So probability, we have 1 chance, so that's 500. So the lose thing is we have like 550. So this one is 498 over 500, and so this one is so this one is 2 over 500. So this one should be so this one is sum of this is 500 over 500. So this is 1. So this one 500 over 500 is also -1. So this one is and so this one is the -2. So should be, so we have a -1. So this one is mu expect value uh expect to lose $1 100 times. So lose, if we do 100 times, 1,000 times, so we lose, expect we lose $1,000. So if we play a game in casino, so when we go for that, and if we like play game at a casino, so you might, that is the possibility, so you can lose the money. You cannot win the money. That's all for the 5.1.